1,000 to 3,000 square meters, like 6 to 10,000 bins storage space.
Yeah.
So this is what I understand when I say or when I hear the term microfulfillment. Now, there's a lot of problems with the concept, and there's a lot of problems with the concept in combination with the technology. So first of all, because the number of bins in the storage system is so limited, you can only get a fraction of the inventory, like of the SKU range that you have in a typical store into the micro-fulfillment center. That's a problem in some stores in Europe. In the United States, where the SKU range tends to be very large, it's a bigger problem.
Wait, but just to emphasize, you said conceptual and technological. This is a technological issue, right?
No,
because it's not the issue with the concept.
It's a
yeah, you can fit much more.
Yeah, true. Yes. So conceptual and technological are related in the limitations of the bin. Yes, of the bin space. Yes.
So, for example, we can fit 5,000 bins in 2,000 square feet, and at the same time have normal throughput. So this is not a conceptual issue, I believe. This is technological issue.
Okay, all right. So I agree. So if I stay within the boundaries of the mature existing technologies, then for me it's a conceptual thing. But you're right. With better technology, we can address that. That's right. So, but let's assume a shuttle system, because you've got your history with takeoff systems, and Dematic has the same thing, and SSI tried to at least slap the MFC label on some of their shuttle systems. Savoy has the same thing. So that's two. Like you can fit 2 or 3 shuttle aisles realistically in the space, right? And so you've got 6 to 10,000 bins. Now, if you have 60,000 SKUs, then obviously that's a tiny share of the SKUs that you can fit into the system. Now, traditionally, what you do when you build a goods-to-person system is that you want to automate the slow-moving SKUs first.
Why slow-moving?
Here's why. So you can pick pretty efficiently any SKU that is fast-moving, because it's not so many. Like the fast-moving SKUs that represent a significant share of order lines, they're not very many. It could be like 50, 100, 200 SKUs, and you can condense them in a very tiny area where you can.
This is a keyword, in a tiny area.
In a tiny area, yes.
So it's like, look, what you just said. You have a power over space, right? How to organize SKU storage, inventory storage in a space. But if you are giving an existing store, let's say you are a huge hypermarket in Germany, and you want to pick out of the 60,000 SKUs, then you want to do in-store picking, then you don't have power over space. Your high frequency movers,
not in the store. You would have to have a dedicated area in the fulfillment part of the warehouse. So you would have to have a manual area. So that's how you traditionally do it. You have your fast movers in a clearly designated, dedicated area where you can pick them very efficiently. And then the slow movers, this is where you normally lose the money. This is where you lose time and productivity in a manual warehouse, because your ratio of walking to picking becomes quite
large. Travel time to pick time, right?
Exactly, and that is worst. That is worst for slow movers. So those are the ones that you want to stow away in an automated system, so you don't have to walk through them. So you can have your cake and eat it too. You can have a manual area that is small, covers a significant share of order lines, and you operate that area manually, and then all the rest you put into an automated system. So the great benefit of that approach is that you significantly reduce the capex, because you already take 20, 30, 40% of order lines out of the automated system, which can save you a couple of million euros. And the system becomes much smaller. And then you have the productivity benefits of goods-to-person picking for the slow movers, and you don't have to replenish the goods-to-person system all the time, because it's only slow movers.
Well, you have to replenish. So you kind of, for this comparison, you invented like one situation where you have high frequency, high velocity SKUs in manual area, and then slow velocity or mid to slow B and C you have in the automated.
Exactly.
And you have to replenish both, right?
Yes, but the thing is, if you have a manual area with fast movers, then you can pick products basically directly out of the source load carrier, which could be a pallet, for instance.
Correct.
And the thing is,
but you also have to merge, right? The
you have to merge.
operation
Yes, that exactly. In the
appears.
moment you split up the inventory, you have to have a consolidation process, which of course is painful, but you have to have it anyway in the micro fulfillment center, and you have to have it in many other systems too.
Well, you have to if you again
in MFC you have to have it because
we have to
supermarkets.
We have to separate in the merge the physical aspect of it, so the material flow aspect of it, and the information flow, because I can show you videos very funny when the bins are right near each other, but to understand that these two bins and these three bins belong to the same order, it's an information decision, right? Like
yes.
So in when you put all of the inventory into automated system, it, like all normal systems, they support the idea that once you get the orders out, they will be together, and there will be easy way to identify that this number of totes belong to the same order, and you can therefore stage them conveniently in the order you want. Whereas in the manual plus automated scenario, you also add a necessity for material flow definition, right? So the automated will kind of spit out parts of the orders on one end, and then you have manual, and then you have to have this material flow to merge orders, but also it has to be supported on the information level from some kind of other system.
Yes.
Because the automated part will not know how the orders are organized in the manual part.
You need to have some management system that is on top of.
And that's why you said painful, right? Because like if you have both very well defined, it's a time.
Painful because you lose productivity. That's why you have to touch the items again, and that's you know, in the end everything is about
you're not touching the items, you're touching bins.
It depends. I mean, it depends if you have transportation if you have transportation constraints, then you want to ship as few bins as possible. So it could very well be that you have a bunch of bins coming from the manual area, and you have a bunch of bins coming from the automated system.
Now you added capacitated vehicles routing problem when the capacity is a real constraint.
Yes.
And when you, of course, I agree. Once you start touching items for the second or third time, it is by now so much pain that it's easier not to do the project at all.
Exactly, and that's exactly what's happening with micro fulfillment centers. You know, let me finish the story, and then I get there, right?
Sure.
So I explain why I think so. So in the traditional systems, you would have the split between manual and automated along the fast mover, slow mover demarcation line, basically. Yeah? So that's the original idea, because you don't need to fix a problem with fast movers. You only need to fix a problem with slow movers. The fast movers are doing fine, very few, and you can pick them very efficiently manually. All right, so in an MFC, they turned it around, or at least in the MFC concept that I've seen, this was turned around. So you would have the faster moving products in the automated system, and you would have the you would keep the slow moving products in the supermarket. And you can only do it this way because there's so many products. So you have to decide which ones are you going to put into the automated system. You can't put all of them into the automated system. There's not enough bin locations for it. So you have to take a subset for reasons of space availability. And this, at least to the information that I've received from all the MFC vendors, have always been the fast movers, whereas the slow movers stayed in the manual store area and the public store area. Okay, so this comes with two problems. Well, first of all, if you put fast-moving products into a goods-to-person system, you are fixing the non-broken part, because you could, if you wouldn't force yourself to stay within the constraints of a store, of an existing building, but you would set up a dedicated warehouse, then you wouldn't have to do this. Now I've kind of forgot what I wanted to say.
So first you're saying you're fixing the non-broken part.
Oh yeah, exactly. You're fixing it. So the fast-moving products, you don't need to automate them because you can pick them manually in a very efficient way already. So you don't have to put them into an automated system. So the resulting productivity benefit from having fast movers in the goods-to-person system is comparatively low, if there is any at all, if you consider that you have to go through a decanting process first, and then probably through a consolidation process after the picking process. So if you take all of that into account, then you might not even have any productivity benefit from having the fast movers in the automated system. Plus, because there are so few locations in the automated system, you have to have what's called a compacting process. You probably would have to work with compartments, with compartmentalized totes, in order to be able to fit more SKUs into the system. So you have very low inventory of most SKUs in the automated system. And then every time, well, and because space is precious, every time compartments become empty, you want to fill them up with something, but you can't go through a regular replenishment process where you start with empty totes and you just replenish any SKU that comes. No, you have to go through a compacting process to free up totes that are like half empty and fill up other totes that are half empty, right? So that's touching the items again. So if you take all of that into account, then you're probably losing productivity in the goods-to-person system as compared to picking those products manually. So that's the first problem.
Oh, it's only the first
just
problem.
one. That's just one.
Okay.
Then,
the second one.
well, the second problem is that you still have all the slow movers in the store. So you retain the troubles of having to pick slow movers. And when you pick from the store, there are two big factors. One is productivity, which isn't extremely high in the store. Now there are ways to make it better, and there are ways to do it worse. And I'm sure companies have come a long way improving the in-store picking process. But there's one problem which they cannot solve, which is inventory management, inventory control. You know, if you're sending an order for 5 avocados as a customer, and that order goes through, right? So you assume you will have 5 avocados by tomorrow afternoon.
Of course, yeah.
And then the picker goes to the warehouse, and just somebody just purchased the last 5 avocados. Then there is no inventory left, and this is the situation you will never be able to avoid in a store, in a public area that you share with customers. And that's actually the bigger problem. If you ask, at least according to the surveys that I've been presented, customers are extremely unhappy about lack of reliability for online orders. And I have friends, for instance, one of my friends, during COVID, he ordered at Kroger all the time. Or was it Baseless? I don't even remember. He told me that every single time some item was missing, every single time.
Yeah.
And he kept doing it because of COVID. But in the moment COVID was over, he stopped doing it because that's not, you just can't accept that something's missing all the time.
Please.
That's the second problem.
Is there a third one? Because I will start crying. I go, you speak through 10 years of my life fighting with these issues. What's the third one?
I'm sorry, I didn't want this.
No.
I didn't want to hurt your feelings.
What's the third one?
So the third one is that let's single out let's single out the productivity issue a bit more. Let's emphasize the productivity issue a bit more. So let's say we've got two shuttle aisles, right? And we have limited building height, let's say 10 meters or something like this, right? That's
a big building, right?
Yeah, that would already be quite okay. So how many shuttles do you get into 10 meters?
Well, so you can have 1 shuttle per level. You can have maybe 8 levels.
Yeah, 8 to 10 approximately, right? So Dematic was advertising 10 levels for 10 meters approximately.
Okay, 1 meter per level. Okay.
Yeah, approximately. give or take 2. All right, so then with a shuttle system, you have this problem that the capacity that you have available is divided into little bins, so to speak. You don't have one capacity for a shuttle system, but you have many little subcapacities. So you've got one capacity for an aisle, but not even for an aisle, but then you have separate capacity for each shuttle level. Plus you've got the capacity of the lift. So in a very naive calculation, you would say, well, we have 10 shuttles. Each shuttle can do, in theory, can do something like 45 order lines per hour, or 45 storage and retrieval movements per hour. So with 10 levels, we get 450 bins in and out per hour. Okay. But that assumes that you have equal utilization of all shuttles all the time, which you never have. And you don't have it for several reasons. First of all, statistically, it's very unlikely that all shuttles receive the same demand, because the products that you have stored in the various shuttle levels, I mean, they say they differ in demand. And especially because we're talking about faster moving products, which have somewhat unbalanced.
Well, you assume predefined storage locations for an SKU, right? But that's a software decision that may kind of jump. You may decide to store that SKU on level 1 in the first cycle, and then 10 minutes later it's stored on level 5. Like every SKU stored in multiple bins.
Yes, if you have extremely good software and you have very reliable data that makes it possible to make any predictions about future demand, then yes, you can do this, but you will still always have the problem that there are imbalances between the different shuttles. So shuttle 1 might be idle while shuttle 2 might be very busy, but shuttle 1 cannot come to shuttle 2's aid and help it, right? So that's not going to happen, because there's no possibility of roaming. So each shuttle fences for itself, which effectively leads to the situation that the overall utilization of shuttles is significantly lower than people assume. And so the amount of bins that you can get out of a shuttle aisle, of any shuttle aisle, is by tendency significantly lower than what you would expect if you just looked at the capacity of shuttles and multiplied it by the number of shuttles.
Well, yeah, I mean, I get it. You speak certain calculations that are typically not done on the client level, on the customer level. This is more designers of systems, those who really think like how the cents and dollars for each shuttles are distributed and how they're utilized. And yes, shuttles are not utilized.
Yeah, I'm thinking in terms of material flow. I'm not even thinking about dollars. I'm thinking purely in terms of material flow.
Yeah.
And so, yeah, and this is something that's not been done by clients. That's right, but it's also not been done by many warehouse automation vendors, which is very disappointing. They don't think this way. And the thing is, in grocery, when you have something between 20 and 40 order lines per order, it becomes even more difficult, because you could balance the utilization of different shuttle levels somewhat if you had something like 1 or 2 order lines per order, because then you could basically say, oh, now I'm going to fulfill this order because that order requires an SKU that is in level 10, and level 10 has spare capacity. But when you have 25 order lines per order, or 30 or 40, then you cannot necessarily afford the luxury.
And they have to be picked in a certain sequence.
Exactly. And you have the sequencing requirements that, like the crash classes that come on top of this. So not only do you have 25 order lines, but you have crash classes. And if you really do not understand what you're doing as a warehouse automation company, then you build a one-to-one pick station
You're picking one order at a time.
One order at a time, which is exactly what Savoy did for Coop Liguria, if I'm not mistaken. I think they built a one-to-one pick station. And, you know, having a one-to-one pick station has been very fashionable for a while because Ocado have one-to-one pick stations. And everybody wanted to be like Ocado, but they did not.
Oh, I didn't know everybody wanted to be like Ocado. Okay.
a lot of supermarkets wanted to be like Ocado.
That's a European trend, probably.
Yeah, probably yes, agreed. So they looked at Ocado and they looked at Ocado's productivity numbers and they saw, oh, Ocado picks 800 items per hour. We want to pick 800 items per hour. We need one-to-one pick stations. But they were disregarding the fact, they were ignoring the fact that Ocado has a cube storage system where you have complete roaming on top of the shuttle, and you don't have all these capacity division problems that you have with shuttle systems.